As I described a couple videos ago, I think resistance combined with ductless systems can be a great application. Similarly, I think thoughtful use of resistance in ducted systems can also be great. I definitely don't think it's always necessary. The systems I described in the previous video, the example, there was no resistance and they did not need any resistance. So it's certainly not always necessary, but sometimes it certainly can be appropriate for various reasons. It's a pretty easy add-on to a central ducted system. Very often you'll see five plus kilowatts of resistance heat combined on heat pumps. It can work great. The challenges come around how you control it, when to allow this to operate. And again, this is all for efficiency standpoint. Limiting the use of the resistance heat and increasing the use of the heat pump can obviously lower operating cost and increase efficiency. One of the challenges comes around defrost. There are some controls for resistance heat and central heat pump systems where when the heat pump kicks into defrost mode, the resistance heat comes on. Usually these heat pumps run in reverse cycle, so you're slightly cooling, you're extracting heat from the indoor air to defrost the outdoor unit. The fans usually turn off or turn down very low, so it's not like you're blowing cold air around the house. But there are some controls where the resistance heat will turn on so that even during a defrost cycle, you're blowing very warm air throughout the house. I don't see that that's necessary in a lot of applications, but certainly it's a comfort decision. And if you think it is necessary, it's just something to consider, something to be aware of. Another time resistance is often used is from recovery from setback. So if you go away all day or if you go to sleep at night and turn your thermostat down, when you turn your thermostat back up, when you wake up or when you get home, some controls will automatically run the resistance because the resistance probably has a lot more capacity than the heat pump and can get the temperatures back up to the set point much more quickly, but also much less efficiently. So if from an efficiency standpoint, I advocate not using recovery for setback. Again, something to be aware of and something to consider on a case-by-case basis, depending on the comfort expectations. A lot of controls have built-in switchover temperature settings. So a heat pump will operate at milder temperatures, but once outdoor temperature gets to a certain value, the heat pump will turn off and the resistance will turn on. It's a viable control strategy. The problem I see is that these switchover temperatures are often way higher than they need to be. Default switchover temperatures might be 30 degrees Fahrenheit, where, the systems I designed, the heat pumps can work down to the design temperature of 0, 5, or even below, well below that. So it is a missed opportunity to turn off your heat pump at 30 degrees, for example, and rely on resistance when it's colder, when the heat pump certainly has capacity to provide heat much more efficiently. So if you use switchover temperatures, be very thoughtful about when you what you set them to, and for best efficiency, set them as low as possible. I want to mention droop. Some controls have a droop function, and there are some different flavors of droop. Droop usually suggests that the heat pump operates as the primary heating source, but if it can't hit the set point, if it's the heat pump's been running for a certain period of time and it's still a few degrees away from the set point temperature, then the controls will engage the resistance heat to bring it up to temperature. It can work. Implicit in that control strategy is a little bit of discomfort. So you're saying, built in, it's like, all right, the heat pump's going to try to maintain temperature, and only when it can't, then the resistance kicks in. So there's potential for some comfort issues. The last control strategy I want to mention is manual control, and this again depends on the application, but I think it can be great. You know, here on this resistance heater, there's a breaker, there's a switch right on the resistance element, and I think a great strategy from applications. I've known people to use this strategy. They put the heater in just in case it's needed. Maybe the heat pump, probably the heat pump will do all of the heating needed, but if there are some extreme events when the heat pump can't make up, or if there are other reasons the heat pump can't keep up, or if there's a problem with the heat pump goes down, an occupant and owner can manually turn this breaker on and then heat with the resistance as needed. Not the most elegant strategy, not appropriate everywhere, but definitely something to keep in mind. It's certainly viable in some applications. So resistance in ducted heat pump systems definitely makes sense for some applications, but if you use it, do think through control strategies to get the best efficiency. Think about whether the resistance comes on during defrost, during recovery from setback. If you use switchover temps, be thoughtful about what that temperature is. If you use droop, again, be conscious of the comfort liabilities. And for some applications, think about manual control. It can make a lot of sense.